So in this question, a boy has stacked 2 blocks on the floor so that a 5 kilogram block is on top of a 2 kilogram block. In the first situation, the coefficient of static friction between the 2 blocks is 0.400 and the coefficient of static friction between the bottom block and the floor is 0.220. With what minimum force should the boy push horizontally on the upper block to make both blocks start to slide together along the floor? So in this question, we are using the equation F equals to mu n, and we are substituting the n with mg because we are considering all forces of y is equals to 0. Therefore, normal force minus weight equals to 0, and which will result in normal force equals to weight, which is mg. Alright, so we are substituting that, and for this situation, we are considering both masses of both blocks. We are using the mu of the coefficient of static friction between the lower block and the floor, because we want only the minimum force. And the only frictional force that will be applied in this situation is the frictional force between the lower block and the floor. Therefore, when we substitute all the values, we'll get 15.09 Newton. So in this second situation, the coefficient of kinetic friction between the lower block and the floor has changed to 0.200. And so we need the maximum force that the boy can push on the top block, but the top block will still not slide off the lower block, and they would still move together along the floor. So we're still using the same equation, which is F equals to mu n and F equals to mu mg, and we are using both mu's between the 2 blocks and between the lower block and the floor. And for the mu between the lower block and the floor, we're considering both masses, but for the mu between the 2 blocks, we're only considering the mass of the top block. This is because we need the maximum force, which will result in the top block still moving on the second block, but not until to the point where it slides off the second block, and both blocks will still slide together on the floor. So substituting all the values, we'll get 33.32 Newton.